Hi everyone, welcome back to the channel. Today's video is going to be a deep 10-minute walkthrough of fully functional Java Deque implementation, and we are going to cover 4 separate code files plus the actual runtime output, all in the one continuous step-by-step demo. To start, open your editor and load Deque interface.java. This is our contract for this Deque, and here on lines 1 through 10 we declare a generic interface, Deque interface T, that requires any implementation class to provide 8 core methods: add to front, T new entry; add to back, T new entry; remove front, back, remove back; and get front, get back is empty and is clear. As you explain, each signature highlights it on screen and emphasize that add to front and add to back handle inserting elements at the head and tail of the structure. Remove front and remove back. Remove and return those elements get front and get back. Peak without removal is empty, checks from 0 elements, and clear empties that queue. Next, switch over the empty queue exceptions.java, which defines a custom unchecked exception class. Walk through its 2 construction on the line. 3 through 8 show how the no arguments constructor calls super attempt operation on an empty queue to provide a default message, and how to second constructor accept a custom string. Stress that we need this exception whenever someone trees the queue or peek at an empty Deque. Then open linked Deque.java, which is the heart of our implementation. Zoom in on the class declaration at line 1, public class linked Deque implementation, Deque interface T, and explain we are following our interface contract. Move down to lines 2 and 3 to show the private files, first node and last node, pointing out that they track to head and tail of the Deque. Highlights the nested DL node class spanning spin 5 through 18. This is our doubly linked node with files data, next, and previous. Walkthrough to constructor on lines 10 to 17. First, the one arguments constructor that calls the full 3 arguments constructor, then the full version that sets data, next, and previous. Emphasize how having both next and previous pointers lets us add a remove from both ends in constant time. Now scroll the no argument constructor on lines 22 to 23. It's simple sets first node and last node to null, creating an empty Deque from line 25 to 36. Walkthrough add to front T new entry. Show how we create a new code. Full check is empty. If both pointer are null, we set both first node and last node to new node. Otherwise, we link the new node in front of the old head by setting new node plus new node dot next equals to first node. First node dot previous is new node, and updating first node to the new node. Emphasize the pointer manipulation and how the operation remains O1. Right after 1, lines 38 to 49. Examine add to back the new entry, which mirrors the front logic but at the tail. We link the new node previous to last node update. Last node dot next equals to new node, and that sets last node to the new node if the queue hasn't empty. Again, highlights that adding at either and its constant time. The next one from lines 51 to 62, cover remove front. Start by calling get front, which we will look at the second. Then check whatever first node equals to last node. If true, remove we're removing the only node, so we set both pointers to null. Otherwise, we advise first node to first node dot next and clear the operate node's previous pointer. We return the data, we pop it, then it remove back. One line 64 to 25. Similar logical applies at the tail. Call get back, handle to a single node condition or otherwise. Retreat last node to last node dot previous and clear the operating node's next pointer. Turn attention to get front on lines when 77 to 84. We true empty, the key exception is empty, returns true, otherwise return first node dot data. Do the same to get back on lines 86 to 93. Emphasize these methods ensure safe peeking out operations. Finally, the utility method is empty one lines 95 to 98. Simply returns true when both head and tail are null, and clear on lines 100 to 104. Set both pointers to null, efficiently decreasing all nodes for the garbage collection. With the implementation fully explained in switch over the Deque demo.java. Explain is our driver class where we set every feature online. 3. We declare the queue interface string. The queue equals to new the queue. Point out we program to interface dot online. On lines 4 and 5 we print our header, testing the queue operation and separate for clarity. Then the 7 calls is empty, printing is the queue is empty, true. Mention this validates or empty state check. Jump to line 9, print adding elements to the queue. Then line 10, call the queue that's add to front. First, immediately call the queue that's get front and the queue that get back. Online even to print front first back first and shows that the new elementary is both head on tail. Online 13 we call the queue add back to back lasts, and lines 14 and 15 print added last to back followed by front first back to last. Confirming back instruction, walk through lines 17 to 19, repeating from inserting of new line and back insert of the new last, each time printing update pointers, so viewers can see the queue growing at both ends. Now on the line 25, we printing removing elements from the Deque. Line 26 calls Deque that's remove front, prints removed from front, new first, then lines 27 and 28 print the new head and tail, demonstrating the state after removal. Line 29 removes from the back, print remove from back, new last, and then show the updated pointers. On line 32 we call Deque that's clear, print clearing the Deque, and on line 34 prints is Deque is empty. True against this confirms our clear method works. Next, on lines 36 to 32, we demonstrate LIFO behavior. Prints using Deque as a stack LIFO, push 3 elements bottom, middle tap onto the front with 3 calls to add front. Then line 40 prints the currently front, tab element equals to tab. Line 41 calls remove front to pop up and prints popped top, and line 42 prints new tab middle, illustrating stack semantic. One line 44 we clear again, then starting line 46 we illustrate FIFO, print using Deque as a QE FIFO, and key 3 elements, first in, third in, second in at the back. Then line 49 prints from front of Deque, first in. Line 50 prints Deque first in, we remove front, and line 51 prints we front second in. This shows key behavior. Finally, on line 53 to 6 we test error handling, print testing error handling, clear the Deque, and warp Deque that gets front. In a try catch, if it doesn't true, we print an error, but in our coach block we print successful coaching exception, attempt operation on an empty Deque, thus demonstrating our underflow exception. With the codes sections covered, switch to your IDEA or terminal and run the program on screen. Scroll line by line through to console output, pausing on each printed line. First testing Deque operations, and they separated by is Deque empty true, followed by every added blah blah and removed blah blah message paired with corresponding front back values, the stack and key demo message, and finally the exception message. Narrate now each console line maps back to the console. We stepped through and enjoying viewers understanding how the operations translate into output. Use on-screen highlights to circle the line as they operate, and remind viewers to like to subscribe if they are enjoying the detailed breakdown. This approach not only shows them how a doubly linked Deque works under the hood, but also how to structure a clear main table Java implementation and test it truthfully. All in one compression, 10-minute video. Happy coding day, and see you in the next tutorial.